Hello, this is Mrs. Jones and welcome to my lesson on energy resources. I've combined the lesson on renewable and non-renewable energy resources into one here. So we're going to be having a look at the different renewable and non-renewable energy resources and their advantages and disadvantages, having a look at some of the different sources of renewable energy and describing how they actually work to produce electricity, and then comparing the advantages and disadvantages, bit of evaluation really, depending on kind of where you are as to what the best renewable energy resource might be and how the use of renewable and non-renewable resources have been changing over the past few years. Okay, so to start with, what I'd like you to do is have a think about the four resources that are pictured and named on this slide, and can you think about what is similar about them all, what the differences might be, just to kind of get you thinking, what do I already know about these resources? Can you say what type of energy they store, and which one do you think, it's really your opinion, is the best and why? So just pause the video and have a go at these tasks. Okay, so hopefully you've had a chance to have a think about these resources. The first thing to say is that all of these resources pictured here are non-renewable, so that's a similarity between all of them. They are used as fuels. Like I said, they're all non-renewable, so that means once they've been used, you can't get them back, you can't reuse them, and they take millions of years to form. Well, these three do anyway. So a similarity between the first three, the coal, the oil and the gas, are that they are fossil fuels, so formed over millions of years underground. The last one here is a little bit different because it's a nuclear fuel. So in terms of the energy that they store, the first three all store chemical energy or are a store of chemical energy, but uranium and plutonium as well is another example of nuclear fuel. It's a nuclear store of energy rather than a chemical store of energy. So uranium's sort of the odd one out really, the way that these three are formed in a similar way. Other differences might be that you think about the state of these, that coal and uranium are solids, whereas oil is a liquid and natural gas is obviously a gas. Sometimes you might talk about the difference in the amounts of energy that they can store, sort of per gram of fuel. Uranium stores a lot more energy than these three do. Coal, you could say, is more polluting in that it has more impurities. So there's quite a few things that you could talk about in terms of their differences. Which one's the best and why? Well, that is down to your opinion. So what we'll do is have a look at some of these during the first part of the lesson. You can think about, once you've learnt a little bit about them, which one you think is the best out of the four. So think about if it was your job to decide on a new power station what fuel the new power station was going to be running on, which fuel would you choose at this point? So from the bit that you know about these four fuels, what would you pick at this point? And I want you to have a think, maybe make a list of a few questions that you would need to ask first. So think about what you don't know and what you would need to know if you were going to make this decision. So again, pause the video and write down some questions that you would need answering first before you were to make a final decision on this. Okay, so listed here on this slide are some advantages and disadvantages of the four resources. Some of them will go with more than one resource. So for example, stores a lot of energy. Well, all of them actually store a lot of energy, so that would be an advantage of each one. And what we'd like you to do is, in the format of your choice, so it could be a table, it could be a mind map or another format, however you'd like to set it out. Have a look at all of these and put them into the four categories for the four different fuels. So coal, oil, gas and nuclear fuel. See which ones of these you think fit in and whether you think it's an advantage or a disadvantage. So again, you set it out however you like. You could colour code it if you wanted to, just so you've got a little bit of information about all of them. So obviously pause the video, do that. You can even log on to Active Learn and have a look at the textbook pages to give you some ideas, and once you've done that you can unpause the video and come back for the answers. Okay, so hopefully you've had a chance to have a go at that. Here is a slide with the answers on, so I'm not obviously sure what format you've set it out in, but you can have a look, pause the video again, have a look here and check that you've got all of the advantages and disadvantages in the correct places. Okay, so now you've learnt a little bit more about the advantages and disadvantages of these four non-renewable resources. I want you to have a look back at the questions that you wrote down at the beginning and see if they've been answered. Have you got any more questions that you need to add that maybe you need to research the answers to? And once you've done that, you can maybe have a think about question 3 and 4. Which fuel would you choose now? So have you learnt about these four, you've changed your mind, or it's exactly the same as what you said at the start? So have a think about what you would choose and why, and give some reasons for your choices. So at least 3 reasons for your chosen power station. Okay, so what I'd like you to do now is just have a look at this chart that shows the usage of these non-renewable resources for generation of electricity in the UK over the last 40 years or so. It gives the percentage up on the y-axis, if you like, and it shows how the amounts of the different energy resources has changed over time. So just pause the video and write a description in your book of how these energy resources have changed over the last 40 years or so. Okay, so just having a look at this chart, if we start with coal, you can see that that's got the highest percentage of use in the UK for generating electricity, so coal-fired power stations. You can see that the amount has, over the last 20 years or so, got a little bit smaller. It is a fossil fuel like the natural gas and the oil, and the amount of both the oil and the coal have reduced quite a lot in the last 20 years or so. Mainly because oil is running out and coal's also running out as well. Natural gas is running out, it doesn't seem to be, but the amount of natural gas has actually increased since about 1985. But again, it is a fossil fuel and it is running out, the supplies are running low. The amount of nuclear has seemed to increase over the last 20 years, but it's been a little bit up and down. But I think probably if we were to extend this graph, we would see that the amount of nuclear energy being used in the UK will actually increase, because even though it's non-renewable, it's more sustainable because there's a lot of it left and it actually stores a lot more energy per gram of fuel than coal, oil and gas. So I think we would probably continue to see an increase in the use of nuclear fuel if we were to be able to extend the graph, and also the amount of non-renewable fuels, would also increase and would continue to increase. But again, we are using more renewable fuels because they are more sustainable, because they are renewable, and with the other fuels, they are non-renewable and will eventually run out. So moving on to looking at renewable energy resources, can you, before we look at it, name some types of renewable energy resource? So make a list and see how many you can get. And then also you might be able to describe how they are used to generate electricity, because most of them work in a similar way, but there are a couple that work slightly differently. So pause the video and have a go at that. Okay, so here's a list of some renewable energy resources that you need to know about for GCSE, and what you can do now is have a go at seeing if you can match up the photographs and pictures to the names of the renewable energy resources that you need to know about. Some of them have got more than one picture attached to them, so pause the video, have a go at that and then come back for the answers. Okay, so here are the answers to the picture matchup. We've got solar power, which has 2 photographs that go with it. We've got the solar panels that you might recognise and see those on the roofs of some houses that are near you maybe. And we've also got the picture of a solar tower where the light energy is reflected onto a tower. So there are 2 different solar power pictures there. Hydroelectricity, where the water is trapped behind a dam and then it's allowed to flow through turbines at the bottom of the dam, and those turbines are attached to a generator that make electricity. Similar to the wind turbines turn around and are attached to an electricity generator. Again, same with tidal power. As the tide goes in and out, it turns some turbines and they will then generate electricity by being attached to a generator. Wave power, there are a couple for wave power. There's the capture chamber here and these barrages, so as the waves bob up and down, you've got little generators inside there, and also in the capture chamber there are turbines, but it's actually the air that gets compressed by the waves that causes the turbines to turn in the wave capture chamber. We've got geothermal, which uses water that's pumped down into the ground where the ground is hot, so maybe near a volcano where the hot rocks are very close to the ground, they get heated up, or the water gets heated up, turns into steam, and the steam drives a turbine. Biofuel is a bit different. It's more like a traditional power station that uses coal, oil and gas. It burns fast growing plants. So with biofuel it's a little bit different because it does release carbon dioxide into the air. Okay, so what you need to do now is make a few notes on each of the types of renewable energy resources that you need to know about. You need to do a little bit about how they work, so a brief outline of how each one of these works, and a little bit about the advantages and disadvantages of each one. So you can use the textbook. There's also a video link to the textbook online. You can do a little bit of research on the internet, but you need to write down a little bit about each one of these, and have a think about as well any that are location specific, so ones that can only be used in certain locations, and also about the availability of them. So some of them are available all the time and some of them are only available at certain times of the day. So try to include information about that as well. Okay, so hopefully now you'll be able to match up these energy resources here along the bottom with these graphs A to D. So each of the graphs shows the amount of electricity generated and the time of day. So pause the video and see if you can match each one of these resources at the bottom to one of these graphs. Okay, so hopefully you've had a go at this, and the answer for A is that it's solar power, and the reason for that is that it starts to increase at 6 AM, which is about sunrise in some places, and then it starts to kind of tail off in the evening and then goes down to nothing at 6 PM. So this one is only really generating electricity in the daytime when there is light, so it is solar. For B, we've got wind. Now, wind generation is very random. It really does depend when it's windy, and sometimes it's at night and sometimes it's in the day, and it can be up and down, but this is quite straightforward. There wasn't any wind until after midday, and about 1 o'clock there was a lot of wind, and it stayed then very windy until midnight. So that one can be quite random, and the graph could look different to that, but it depends when it's windy. Then for graph C is tidal. You get this sort of predictable energy production when the tide goes in and the tide comes out. So tide goes in, tide goes out twice a day. So again, it's not available all the time, but it is available at predictable times. And then the last one is hydroelectricity, because with hydroelectricity it is available any time because they can allow water through the dams at any time. So it's just a steady production, pretty much a steady production of electricity throughout the day. Okay, so now you've done quite a bit of work on renewable energy resources, pause the video and see if you can answer these 5 questions, and maybe even the challenge question of why can't we use renewable energy resources to generate all of the UK's electricity at the moment. So pause the video, have a go at the questions. Okay, so hopefully you've had a go at these recap questions. So what is it that powers most of these resources? And the answer is the sun. So indirectly the sun will cause most of these energies to be able to be used to provide electricity. Obviously solar is directly driven by the sun, but most of the others are also driven by the sun. Which resource is available at all time? Well, hydroelectricity is, geothermal is, and also biofuel. The others have limits to when they're available. Which ones are available at predictable times? We'd say tidal and solar, so not all the time, but we can predict when the sun's going to rise and when it's going to set, and we can also predict the times of the tides and when they're going to come in and out. Which resources are location specific? I would say that geothermal is location specific because it needs to be a place where the hot rocks are close to the surface, so a volcano for instance. Iceland produces a lot of their electricity using geothermal. Tidal as well, location specific, and wave because they both have to be near to the coast where we've got the sea and the tides and waves. Disadvantages of biofuel. The main disadvantage of biofuel is that it's combustion and it's burning, so it releases carbon dioxide into the atmosphere, whereas the other resources don't release carbon dioxide into the atmosphere, which we think is contributing to global warming and an increase in global temperature. We can't generate all of electricity in the UK from renewable energy resources, mainly because it does not produce enough to meet the demand, so it needs to be backed up with the traditional power stations or nuclear power stations. Okay, so a little bit like the previous task on non-renewable energy resources, I want you to have a look at this chart. So the amount of energy produced by different renewable energy resources since 1990. So have a look at the information here, pause the video, and first of all describe how the renewable resources in the UK has changed since 1990 and give two possible reasons for this change. So pause the video and have a go at that. Okay, so hopefully you've had a chance to have a look at that chart and just see what it's telling us. And we can see that overall the amount of energy being produced from renewable energy resources has increased a lot since 1990 and will probably have continued to increase past the end of this chart that's shown here. You'll be able to see this also in the textbook. And you can see there's a lot of biofuel being used, and I think because we want to try and preserve the fossil fuels, because they are running out, that's possibly the reason that biofuels has increased so much and is quite a large proportion. But we've got other things in here as well, hydroelectricity and some of the other, which includes wave and tidal power and geothermal. We can't really use a huge amount of geothermal in the UK because we are not in a place where the hot rocks are close to the surface, so that's more useful in places like Iceland where there's a lot of hot rocks close to the surface. Can use geothermal, but not really in the UK. You can see there's a bit of hydroelectricity being used there as well, and some wind power and a little bit of solar. I know that lots of people are starting to get solar panels on the roofs of their houses, so would expect that to have increased as well since 2014. So reasons for it are preserving fossil fuels and also reducing the amount of carbon dioxide that's being put into the atmosphere and other pollutants as well, such as sulfur dioxide. Good reasons really. So reducing the amount of pollution and of course carbon dioxide into the atmosphere, and also the fact that we want to preserve fossil fuels as well because they are running out, and oil is used for other things as well, like making plastics for instance. So if oil's running out, then we're going to be in trouble. Okay, so this is just a little optional task to finish off the lesson. You can have a look at these examples of renewable energy resource in their triples and say which one you think is the odd one out and give a reason. There's more than one answer to each one, but just to get you to think about which one is the odd one out and give a reason. And that brings me to the end of the lesson on energy resources, so renewable and non-renewable energy. Hope you found it useful. See you next time.